I think it's narrower in scope, and it goes like this: how to organize an educational space so that each participant is a researcher outside of the school subject. Now, I have to admit that I don't fully understand this entire the question in the entirety, but I can see that at least in the sentence there is this each participant is a researcher. Now, this word researcher is a very difficult one. I have not met it very often because now again I'm referring to what I said. Research is not an individual activity. There are researcher jobs in university, and you are a researcher. But that, of course, means that you have a big network of people and information, and you are sharing common goals with them, and you have your own part, your own speciality you add into the bigger picture. But without your group, your own speciality is not really so valuable as it is as a part of a bigger group. I have been lucky to meet some great researchers, and they agree, at least as far as I know, that without the context and the group and the research community, they wouldn't be doing much. So I would like to skip this one because this the idea of lone researcher somehow doesn't appear to me. The educational space organization is of course another issue. In best cases, we would have a space for laboratory work, that says laboratory with appropriate tools, and then we would have another space for teamwork and analysis, and then of course the interaction with the teacher and others. So it's obviously a group activity, and that means that the educational space has to be organized in a group activity manner. Then of course it's not always possible, and of course it's not always the case that the work is done in laboratory. It's in the best of cases it's done outside, probably in some interesting place like well out in the nature with tools, or then probably in the specialized laboratory. Very unlikely, but possible. It was mentioned in the last question, which I will come later to. So yes, there are many restrictions, unfortunately, and in technology and science, it's a bit hard to imagine a situation where you do research without any tools or experimental elements. So we are fighting hard to press this particular issue that there has to be something to do with your hands and with tools, and have some sort of scientific activity. What we can go more precisely what that means, but the scientific means that you are making observations, and you have this observation to common observation to theoretical understanding, and further problem setting mindset. So there is this part of observation, and there is this part of analysis and cooperation to that. So most likely it's a teamwork type of environment, at least in the latter part of a project. In question number 3, there is this problem. is there a need to build an individual educational trajectory for the student, that is research diary project work, in working on each project? This individual trajectory, I have a little bit difficulties. Now this far you know that I am emphasizing the teamwork. Of course, there is a situation when this someone, probably maybe someone of the pupils, or for some other reasons than pupils' own desire, you have to go to individual route way. But that is not. I would almost say that working alone is not very scientific thing. You can, yes, you can make an experiment all by yourself, and you can make analysis all by yourself, and you can write an essay or a report of all that work all by yourself. Unfortunately, that is what we did in Oulu University when I was studying physics. And later on, I learned we didn't feel very good about it, and what that led into was a widespread copying of results and reports. So it was not the optimal way, but that was that's a simple way. You perform a measurement and you make a report and you give the report and you get your scores. Cool. But it's a simple way, simple organized, but it's not something that you would call true, honest scientific work. Not at the most of the times. That's what I think. So the teamwork in one way or the other is the key. You can ask for individual works, but they are usually quite simple. They are quite demanding in many ways, unless of course you do copy pasting, but that's not what we want to have. Restrictions are always a problem. Okay, in the worst case, if it really goes so bad that you don't have any tools at all and you have to go to some probably invented data, well, luckily enough, there are sources you can, for example, you can make a measurement and you can have a YouTube video in which a measurement was made. That there are quite a lot of researches, so you can use the data from some existing experiment, but at least you should witness the experiment in terms of YouTube video or something like that in order to grab the touch of the reality there. In an experiment that we did, I had to then was this major problem, and I was trying to make an experiment of aerodynamic drag of a falling table tennis ball. Right. I was trying to make a table tennis ball fall and track how it slows down because of the air resistance, and I failed badly. And then after the failure, I realized that I should make some calculation, and I made some calculations, and I found out that I had not enough falling time. Actually, I found out that if you want to make that particular measurement, you need to drop it at least 8 meters to have any reasonable data. And well, we didn't have any room with 8 meters height and still airs off. We blew it. But luckily we had some nice YouTube video with similar data, so we could simulate the idea. But we had this very successfully failed experiment. That was also an experience to try something and find out that okay, this didn't work, and then find out why it didn't work, and then have the solution to your problem in another way. So failing is it's okay. You can fail a constructive way, and you can have fun doing it. and that's perfectly all right. As I mentioned yesterday, probably 10, more likely 2% of any initiatives in technology branch ever lead to anything. So it's risky business. To the number 3 question, I don't think so. But you can have different approach. In my teaching, I try to observe the skills of research as skills of cooperation and a positive input to the teamwork, and that's good enough, because we are different and you cannot expect the same sort of input from different personalities. So each and every student is expected to put his and her best to the work at hand, and that's enough. That's good. We cannot ask more than your own personal best. That's a reasonable assumption of a teacher. Yes, in number 3, number 3 was probably the question goes on asking, how do you know that your children are ready to study? Well, I don't. I give them a problem and I will see. And if they are not ready, they should be asking questions, telling me that, okay, you were asking too much, not today, you have to give more input. But it's an interactive process, and it's a question of observation. If I give work to the team, I will observe and see if it succeeds in any way or not. And if not, then I have to give some more input. And if still not, I have to give something simpler. But it's not a good idea to give too difficult task or too easy task, because the best task is the one that brings you forward. So my answer to the second part of the third question is observation. If you do it honestly, and if you are honest to your children and yourself, to your pupils and yourself, then you probably should be having quite a good impression of those skills. And there is the starting point, and then you start teaching. Okay, then we go into the technologies used. Again, the question number 4.
Erkko, may I? Sorry.
Oh, yes, I am sure you have more wise words about this.
This question about are children ready to study? Well, I know we are now discussing about students in secondary level. They are teenagers, but if you are interested, let me shortly share with you latest news from the Finnish context. There was a research done amongst first graders. In Finland, they are 7-year-olds. And the results briefly say that the learning capabilities of 7-year-olds, the students may have even 3 years difference. In other words, whereas some of the first graders barely recognize a few letters here and there, or maybe not even them, but most of them do. There are some 7-year-olds who are already reading novels. And this is quite interesting also to think of. Of course, by age and by time they grow up and they gain new skills, and perhaps these differences more or less become flattened by time. But I think that this sort of differences may exist, and the research gave us some reasons at the background for the great differences between the students. But what is also interesting is that this is a long-term research that is ongoing, and the next time the same children will be researched in 2 years' time when they have finished the grade number 3. So we will also wait and see what on how these differences have been leveled, if they have or not?
Yes, the inequality or the very different levels of skills are really a challenge to a teacher, because as teachers we should create research groups in which each and everyone could work. And sometimes the differences are so great that it really turns that the group does not work. There are too big differences in levels of thinking. But we should do our best to level out, and we should do our best after we learn how these pupils are. We should create and make the task setting such that each and everyone could participate, or then divide the work, give easier jobs to some groups and then more challenging jobs to some groups. But it's a huge task. It really takes a lot of effort, and it takes a lot of thinking to make that happen, and it most often doesn't really happen. But we always should, of course, try our best. There are so many ways, and probably and most likely the teachers already have their own strategies and so on. So that's a big challenge. Yep. So now we are ready to go to question number 4, aren't we? Good. Now the next question jumps to the worldwide issue, and that is to which degree do the teachers need the ready-made materials? So in what format should we expect methodological support for teachers? Will there be recommendations, list of resources, set the necessary educational tools be prepared? And yes, teachers wait for the list of materials, use this box of tools, or try to find or have like the things readily thought for them. And there is a wealth of material, like if you go to this goes to quite much. This goes to goes to USA, where these are very, very well prepared, and they are the material is just overwhelming. If you go, for example, to the code.org, that is the coding courses, there you have this hour of code and so on, and you pick some of those lessons there and look at the data and look at the material. It's just overwhelming how precisely and minute by minute they have thought this would happen. They give you a number of minutes you should use, thinking of this and this and this point. And well, it's probably very good support, and it probably helps a lot of inexperienced teachers. But of course, it's only a model. It's only one view to the task at hand. So of course, the teachers do make their own decisions of how much time to use and which parts of the project to emphasize. And also, if you go to, for example, if you go to this robotics, which is quite common view that you'd have, for example, some sort of Arduino curriculum, and there are also very, very well thought out paths of experiment, and they are good. They are very, very nicely thought out, but then again, they are thought out in one way, and you probably don't agree with the maker of the kit with some issue. Then you have to make your own decisions, and the best material is of course such that it gives you a chance to modify or work out yourself some experiments and so on. This goes now a little bit personal. I love to make materials myself to a degree, but I also find out that the materials that I make and curriculums that I plan really don't work out so well. I always fail to think some part of it, and I always find out that okay, this was not so clear to the listener. I have to talk more about this, and then there are some things which are obvious to the listener, and I shouldn't use so much time. But at least I'm learning myself during the process. So, in what format should we expect this support? Well, that is the question you have to ask at your community. Usually, the best materials are made by teachers themselves, but not alone, but in groups or in teams. So if you have any chance to bring together like local teachers who are interested to create some materials, that would be probably the optimal thing, because if you have teachers who know the culture and teachers who know your local curriculum, then you have most likely the teachers who can invite the best and most suitable projects and materials for your task at hand. It's not something that you can really rely on an outsider to know. At least I have not found any materials made by an outsider too suitable to our use, only because the timetables are so different and so on. So, and then again, one more thing, creating these materials is usually a very, very light activity. Teachers love to get together and think about the work they are doing and to create materials for each other, just as long there is some sort of what do you say, reward reward for that. So usually when you get the teachers who are involved, who are interested to a team to create materials, usually the result is the best for you. And yes, the internet is full of good ideas. Just pick yours, and that would be good. It's no use to try too much to begin with, because you can do the scientific method you can do with very little resources. So it's not, it should not be like too expensive. Question number 6, and it goes to the fact that there are always, everywhere there are chances to go really long, and this refers like error modeling, and there are these special, let's go, we have these special people, probably teachers or researchers who are really, really deep in their profession, and you would like to use their input to your STEM classes. Now, unfortunately, it's impossible. You cannot, if you have an entire city of schools and you have probably one scientist you want to share with all the pupils, so you cannot have it very interactive. But in here also there's some sort of pyramid approach, that there is like an easy level of interaction for big amount of people, and then more involved interaction to the more interested people, so that everyone gains his and her level of knowledge. And so here are this also this question number 6 refers to this amateur radio, which is really really exciting, but at the same time, it's sometimes it's costly. Sometimes it takes time to travel back and forth. So it's just the simple fact is that it's not possible for everyone to attend to such a high-level activities. Luckily, we do have Zoom, and we do have other ways of interaction, so that you can at least give a taste or a glimpse of these fantastic things that you can achieve. And most important, usually the most important thing is the interaction with people. Just to meet those enthusiastic people who have achieved remarkable things in science or technology is very, very inspiring. And it doesn't have to be so much for many people. It's very often we tend to think a little bit overdo these things. Also, a little amount can be very, very important, the motivator, and important in a way that the pupils can make their mind if this my stuff or if this interesting from me or not.
We have been collaborating with Almas for closely 2 years, every now and then. So it's only one example of our international network that we have been able to collaborate with. We organize on behalf of the Oulu University Teacher Training Schools in-service training courses, either on-site or online. Obviously, today we have only online courses, since, as you all know, nobody is traveling at the moment, and we are not able to accept any visitors to our school. We have had previous examples of and experiences of series of courses or even webinars being ones like this, a bit shorter courses of a variety of topics. We have got ready a few of them by now, and I'm happy to share the list of these courses with Almas by email, and perhaps this kind of online webinar series can be continued in the very near future. The webinar or the course topics are naturally they are related to the Finnish educational practices. Personally, I believe that we are happy to give you and share the practices, examples, even theories that we are practicing in Finland. But personally, I have always said that the system and the models, the lesson plans and so forth, they cannot be exported as such. They always must be somehow implemented in the local context, and they must be adjusted slightly to fit the current situation and the framework that is existing in your case in Kazakhstan. But we believe, however, that the courses will give you some models, some ways. We are able to show you some cases how things are run in Finnish classrooms, and perhaps this way you are able to then have new approaches, new teaching methods, maybe new assessment practices and so forth that can be implemented in your schools. As said earlier, I've spent some time not only in Thailand but in other countries personally giving in-service training courses to teachers, and the contexts and the environments in different countries vary a lot. So it must be also a realistic approach on our behalf, that what we are trying to achieve with this cooperation with us. But in short, yes, it's possible, and I'm more than happy to receive more information about the subjects and the topics of this kind of training, online courses. The main question is that I give to you is that what are your needs? What do you want to develop? And maybe we can continue from there. And if I may suggest, Almas would be the contact person. Thank you.